All right, what do you need to know about programming if you are just getting started? We all have to deal with certain tasks in our daily lives. Many we can solve on our own, while others, especially the ones that are more complicated, can be solved with the help of a computer. Assume you have defined a problem that must be solved and you know the steps that must be taken to solve it. Even if you could structure your logic perfectly and type a brilliant solution in English, the computer will not understand it, as it understands zeros and ones only, no other symbols. Similar to a light switch, it recognizes two phases, on and off. To communicate a real-life problem to the computer, you need to create a specific type of text called a source code or a human-readable code that software can read and then process to the computer in zeros and ones. A program is a sequence of instructions that designate how to execute a computation. Therefore, the formal definition of programming is the following: taking a task and writing it down in a programming language that the computer can understand and execute. You need not be a geek or computer scientist to program. Actually, the subject of computer science is not the study of programming. These are different things, and this can confuse beginners. Computer science is about understanding what computers can do. Programming, instead, is the activity of telling computers to do something for us. Think about the world we live in today. There are more than 1,000 programming languages out there, and each language is designed for carrying out specific tasks. So, depending on the sphere to which your problem applies, only some languages can be of good use. For instance, PHP is good for web programming, but is not suitable for programming devices. C++ can definitely help you with the latter, while Python and R are some of the favorite tools of data scientists and people from the finance industry. When you meet an experienced programmer, don't think he can program in all languages out there. Instead, it is likely he can work with one or maybe a few languages, but he has mastered them well. Right, but how does somebody become good at programming? First, programming requires problem-solving skills and involves abstract thinking. You are supposed to understand your task perfectly and then break it down into a sequence of instructions or smaller computational steps that the computer can execute. For example, John is asked by his boss to do the following: create a program that adds 10 to any number his boss inputs with the keyboard. The correct reasoning would be, if x is the unknown provided, we need an output of x plus 10. After you have created these steps, with the help of a programming language, you will type in beautifully organized lines of code. So, the second crucial thing to develop is mechanistic thinking. Unfortunately, computers can only execute what you ask them to do, and they won't understand what you imply by the instructions you have provided. They will simply compute the code without interpreting your output. Fortunately, we can do that though. Humans can understand and interpret code instructions and adjust it whenever necessary. And this is why a solid knowledge about the syntax of a programming language and the ability to understand computer code is of paramount importance. It will positively affect your thinking process, allowing you to break down your problem into parts the computer can execute. In the example we provided above, John must think of the following subtasks. First, he must define a function that takes x as an argument and then returns as an output a new variable equal to x plus 10. This is how this problem can be solved. Regardless of the problem you are facing or the programming language you are using, your coding style is crucial. Remember that. Having 3 lines of code is straightforward to understand. However, in practice, you will likely work with hundreds of lines of code that must be sent to other people. If your work is difficult to read, unnecessarily complicated, full of variables as names, conveying no meaning, it will be poorly received by other programmers. Therefore, throughout this course, we will pay attention to the best practices that will help you organize your code. Programming challenges are great as they develop your mechanistic thinking and problem-solving abilities. This involves formulating problems, breaking them down into meaningful steps, and communicating these steps to the computer in an organized way. This will do for now. Thank you for watching. Although it may be new to some of you, Python has been on the programming stage for over 2 decades. There are 2 main reasons you should learn Python. First, it has several technical advantages compared to other programming languages. And second, its practical application covers several industries. It is a powerful computational tool when we have to solve complicated tasks in the field of finance, econometrics, economics, data science, and machine learning. Therefore, it is a perfect stepping stone for somebody who learns how to code and is determined to pursue a career as a data scientist. Here's a slightly more technical description of Python. It is an open-source, general-purpose, high-level programming language. Let's break this definition into several pieces and try to understand each of these attributes. Open source means it is free. Python has a large and active scientific community with access to the software's source code and contributes to its continuous development and upgrading. Depending on users' needs, this is the main reason Python is cross-platform. It is available for all major operating systems, Windows, Mac, and Linux. The benefit of it is Python can be quickly applied anywhere. Domain-specific languages like MATLAB and SAS, also used for solving financial and econometric tasks, are paid. This plays a role in a language's popularity. General purpose. There's a broad set of fields where it could be applied. For instance, Python can be used for web programming through the Django framework. Although this is beyond the scope of this course, you should be aware of the wide scope of application, and the interoperability with other programming languages could be an explanation why some large organizations have chosen Python as their main programming language. High level. This is slightly more technical. Broadly speaking, computers can run programs written in low-level languages only, also called machine languages. So, a program written in a high-level language must be first interpreted into a low-level language before it can be executed. This process takes time. There is specialized software and applications that will do this interpretation for you. The advantages of using a high-level language are huge. It is difficult to code and understand low-level programming languages. They are too technical. High-level languages employ syntax a lot closer to human logic, which makes the language easier to learn and implement. It allows the programmer to focus on the task at hand, instead of trying to figure out unreadable lines of code. To summarize the technical advantages that make Python a powerful programming language, often preferred over other programming languages, we can say the following. It is free and constantly updated. It can be used in multiple domains. It does not require too much time to process calculations and has an intuitive syntax that allows for complex quantitative computations. What we've said so far demonstrates Python's enormous practical applicability. It is clear we are living in the era of big data. People in different disciplines, economics, finance, computer science, marketing, and many more can retrieve huge amounts of data. We can talk about big data when we have millions of observations. In such situations, the computational capabilities of traditional data processing applications like Microsoft Excel become insufficient. We need a more powerful tool to tackle big data in more or less the same way, regardless of the field application. Python is perfect for these situations, as it gives us flexibility. To conclude, Python's popularity lies on 2 main pillars. One is that it is an easy-to-learn programming language designed to be highly readable, with a syntax quite clear and intuitive. And the second reason is its user-friendliness does not take away from its strength. Python can execute a variety of complex computations and is one of the most powerful programming languages preferred by specialists.